joosta.
Teine asi, mis seintega on, pidagem seda meeles, et ehitus esiteks tellis või see betoon kuidas öelda, kahaneb või tõmbab kokku, eks ole, esimese 28 päeva ajal väga palju ja siis kogu aeg alati natukene ehitus kuni infinitum, aga siis juba ainult väga-väga vähe, aga kogu aeg natukene. Kui me paneme selle ehituse sinna või selle välisseina jäigalt, mis siis juhtub? Nii, ta paindub ja ta läheb katki. See sein siis ühe sõnaga peab ka sedapidi liikuma. Nii et see on ka jälle väga-väga, see ei ole lihtne, kuidas seda teha. Ta on veekindel, õhukindel, aga ta liigub, saab liikuda. Tuleb päike peale. See koht, kus päike tuleb peale, on vahest nii kuum, et sein läheb nii kuumaks, et praemune. Ja seal kõrval, kus päike peale ei paista, võib olla täiesti nii külm, kui ta eile öösel külmaks jäi. Nüüd nende vahe. Sein paisub, kus ta on soe. Tõmbab kokku, kus ta on külm. Jälle liikumine. Mis juhtub? Kui me jälle ei ole teinud korralikult kõik need mõtted läbi, vabrikus kokku pandud ja ei lase läbi ja teeb kõiki neid liigub sedapidi. Võt, see on, mis see sein on.
Henno Sillaste parem käsi paljude majade rajamisel on aastaid olnud insener Werner Klouk. Kanada seinte hingeelu tunneb see mees väga hästi.
Curtain wall is the trade name. It's first of all, those walls are dynamic. They move with the building. And they're made in frames and they are hooked together to be then a structural component. There's nothing else in the wall except this Canadian wall. And this wall is thermally very efficient. So we don't have a lot of heat loss. And what's more, in the summer is heat gain, so they don't have to have as much air conditioning. And also, it works well as far as weather. It's very airtight, and it doesn't let in any rain because of a system called the rain screen system, which was developed here in Canada. What that means, that you leave the exterior open. The old method is that you seal off the outside.
So the science helped the architecture?
Exactly. The science helped the architect. Well, the architect's dream can be realized with that wall, and so that's basically the thing that you listen to what the architect wants, and then you design your wall to suit that. And one of the nice things too is you can apply different finishes, and you can make it look whatever you want to make it look like a glass wall or aluminum panel or stainless steel, or you can make it look like a concrete building or granite. Like in some cases, it's done here. The architect has a free expression on this building. He can express himself, or with this type of wall, he can express whatever he would like to, and you can express it with that wall.
Vaatame nende hingavate seinte sisemust nüüd veelgi lähemalt. Kuidas need mitmekihilised plokid, mida välisfassaadides kasutatakse, siis tegelikult toimivad?
And it's basically made out of layers. And these layers are a structural component. a component where they hold the glass or retain the glass or any other materials, and there is an exterior layer. The big challenge for a wall is to have it built in a way that it can actually move with a building movement, because buildings are not static, they are dynamic and they're constantly moving under wind loads, under temperature changes.
Okay, these are the new bricks of the building industry.
Yes, these are the new bricks or the wall. Let's call it the wall because they're not bricks anymore. Originally, when they built bricks and masonry, the brick and the masonry was the structure of the building. That was a wall which held up the building. But you were very limited in height. And if you were over 5 stories, you couldn't build it anymore because you would have, your walls had to be that thick. So since they we needed to build much higher, we separated the structure from the wall itself. And that structure was built separately in a very efficient way. It was either steel, a steel structure, or concrete. Now, on these floors, which are out of concrete, you would attach a very light wall, and it was in comparison not very thick.
Et need suured välisseinaplaadid paigaldatakse karkassile, ei vajata majade ehitamisel enam tellinguid nagu varem. Ning nii seestpoolt ehitades saab püstitada ka väga kõrgeid hooneid.
You can go on as much high as you want to do, because you can design for wind loads and you can design for the requirements, the movements, but there's been buildings very high. You can go easy, 100 stories.